Okay guys, now we are going to see that how we are going to calculate the magnetic behavior of the complex. Basically, it is mainly calculated using the formula which is given by mu is equals to root of n into n plus 2, which is called as, that is, this mu is called as magnetic moment. Magnetic moment, and that of your n represents the number of unpaired electrons present in a complex. Let us choose now how to solve it. Okay, so basically, if you have been given with, in VBT we have solved the complexes, just I am taking that one directly, COF6 3 minus. We came to know that this complex is paramagnetic in nature. Yeah, so how we came to know it is a paramagnetic? When you are choosing the overall complex, we came to know that it is having the final representation as 1, 2, 3, 4, and overall over here can just refer to the VBT concept what we have dealt earlier. I'm just taking the last part, and we came to know that it is paramagnetic because of the presence of the unpaired electrons. If for this complex I have to calculate the magnetic behavior, what I will do, mu is equals to root of n represents what, your number of unpaired electrons. How many unpaired electrons are there? 1, 2, 3, 4. So 4 into 4 plus 2. That will, you are going to get as root of 24. That is, root of 24 means how much? You have to calculate. That is root of 24. That is equals to 4.89. Remember, it is Bm, the unit of the magnetic moment, which is called as Bohr magneton. So when you are choosing for a COF6 3 minus complex, we are getting the magnetic behavior or magnetic moment value as 4.89 Bohr magneton. If I am choosing a complex of NiCl4 2 minus, so there I can represent the final part as how? In this way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 1, 1, and over here so this is my final structure of a complex, how will be the electrons present over there. And there I could notice that it is also a paramagnetic in nature. So if I want to calculate its magnetic moment, how I will do it? Can you please say what will be the value of my n over here? Very good, that is 2 into 2 plus 2. Alva. So how much you are going to get over here? That is 4 2s are 8. 2 plus 2, 4. 4 2s are 8. So what will be your root 8 value? Of course, 2.828 Bohr magneton. But now when the question arises, if you are just choosing any complex which is a diamagnetic, that is, for example, CO NH3 6 3 plus. Of course, we came to know that here it is a diamagnetic complex. That is, all the electrons are paired. Can you please say what will be the value of mu over here? Of course, 0. 0 Bohr magneton. That is, whenever there is no presence of an unpaired electrons, the resulting value of your magnetic moment will be equals to 0. So our magnetic behavior is mainly dependent with respect to the number of the unpaired electrons. You can just notice over there, higher the number of the unpaired electrons, higher is the value of its magnetic moment. In the first case, there were 4 unpaired electrons. I got a value nearly equals to 4.89. But in the second case, when it was just 2, I'm getting the value of nearly 2.828. You can just notice both the things. Higher the number of the unpaired electrons, greater will be its magnetic moment. That is, greater will be its magnetic behavior. Unless and until they are not having unpaired electrons, what you can say, they will be having no magnetic behavior, or in simple terms we can say that they will be having zero magnetic moment. Coming to the last part of this chapter, which is called as applications of your complexes. Basically, I would like to deal with one of the most interesting thing which we have not dealt in these classes, but in the higher classes we are going to see that basically this complexes concept is used in the quantitative and a qualitative analysis. That is, in simple words, if I have to say that whatever the titration we have done in our first PUC, the same way there we use our phenolphthalein as an indicator or our methyl orange as an indicator, which was indicating us as the final end point. But in such, here what we are going to do is, in case if you have been given with a water and you have been set to determine the amount of the calcium or the magnesium, that is to measure the hardness of the water, which are the main responsible culprits are your calcium and magnesium part. And in case if you have to determine it qualitatively, how much present it is, and quantitatively, then we will be using an indicator as that of your EDTA, ethylene diamine tetraacetate. What it will do, now it will act as a ligand, and this will bind with that of your calcium or magnesium specifically in a specific medium and giving you the color change. And with respect to the particular value, whatever you are going to get, by using that value we will be able to calculate that what would be the percentage of the calcium or the magnesium present in the given water. So this is the main application what we are doing in a qualitative and a quantitative analysis. One more most important enzyme, this one also we are using ligand called as a dimethyl glyoxime. So this is also a form of your EDTA itself, which also acts as your ligand over here, dimethyl glyoxime. This is also one of the major important two titrants what you are going to use in order for the qualitative and a quantitative analysis. Of course, in metallurgy, if you have read the chapter, you will come to know that when we were doing the leaching process, of course we have dealt in the class also, we came to know that whenever we have to extract the gold, first we are converting the gold to some cyanide complex. You can just refer to the notes what I have given. That is, first we are converting it to a complex, then by using zinc, what you are going to do, you are going to decompose it and you are going to extract the gold. So for the extraction of the minerals also, this complex concept is very much important. Even for the purification process, which is called as a Mons process, where you are converting your nickel by treating with respect to that of your 4-carbon monoxide in the thermal decompose. First you convert it for a complex of NiCO4. Then you are going to decompose it at a very high temperature to extract a pure nickel. So for this is called purification technique of your nickel, because called with respect to a Mons process. Thermal decomposition process ಅಲ್ಲಿ one nickel ನಾವು purify ಮಾಡಕ್ಕೆ first the complex ನ ತಯಾರು ಮಾಡಿಕೊಂಡು first you are preparing the respective complex, then you are heating it at a very high temperature to extract the pure nickel. So here also the concept of the complex plays its vital role. If we go with respect to the nature process, there also we could see, if you can just see that all the human beings are need of what? Plants, because they give us the oxygen. But where does it comes from? Of course, while during the process of your photosynthesis. But in plants, the photosynthesis has to take place. What the pigment is necessary, of course, is your chlorophyll pigment. But when we are doing an analysis of what is the structure of this chlorophyll pigment, you will be astonished, because there also we will be having a complex of your magnesium. That's a chlorophyll pigment also consists a structure of a complex which is made of your magnesium. Even within our blood, whatever we are seeing as a hemoglobin, it is also a complex of the iron, which is acting as an oxygen carrier throughout our body. So in our biological process also we can see the importance of that of your complexes. Coming with respect to the medicinal field, of course I have dealt with it in my earlier classes. I don't know how many of you are remembering it. I said that cisplatin is one of the most important drug which is used as a cancer treatment drug. It's actually a complex of your platinum, PTNH3, NH3, Cl and a Cl. Basically, this is called as that of your cisplatin. Why cis? You can just see that cis and why? Because the similar groups are present on their adjacent sites. That is the reason this is called as that of your cisplatin. Remember, transplatin has not having that effect of treatment of the cancer, but this cisplatin, which is a complex of your platinum, is one of the effective drug for the treatment of the cancer. So these are the main applications what we are dealing with respect to the complexes. Even though in our body, even though in our nature, anyway you just see we are bound with respect to the complex, and in the present scenario all these scientific researches are taking place with respect to these complexes. So this completes your coordination chemistry. If any doubts, you can just post me the doubts in the WhatsApp group. I hope the videos were clear and understandable. Any doubts, anytime, I will be very glad to clarify it. Thank you.